Hello everyone, welcome back to Tech Gear Guide. So in today's class, we are going to do linear regression algorithm in a practical way. We are having a dataset known as salary prediction dataset. So the dataset contains two types of variables. First is independent variable, that is years of experience. Then we have dependent variable, which is salary, because it is dependent on the years of experience. So now let's start. I am going to do this algorithm, or you can say practical, in the Google Colab notebook. You can go to any browser, any search engine, and just search Google Colab notebook, and then you can start working with it. I'm using Google Colab notebook. You can use any other, just like Jupyter notebook and or any other smart interface. So let's start. First command is to install the different libraries we need to perform the algorithm. First is pandas, second is numpy, then is matplotlib, and fourth is scikit-learn. Remember, when you're working in the Google Colab notebook, while installing, you have to use the exclamation mark in the starting. Fine. And you can see that we are while we are installing the scikit-learn, you need to write the scikit-learn. So the next step is to import the libraries. We are importing pandas as PD and numpy as NP. Then our next step is that we are going to take a variable known as data, in which we are going to store our dataset. So data is equal to PD dot read underscore CSV. Here you need to understand that read underscore CSV is a function of the pandas library. Then in parentheses, we need to give the address of the file. So when you are working in the Google Colab notebook, you need to know that you have to upload your dataset in the file section. Then we can copy the path of the file and just paste it in the parentheses. After that, we can call the dataset data, or you can write data.head. Head is the function of pandas which returns the first 5 rows of the dataset. So the next step is to understand our data clearly. So to understand and reevaluate our data, we are going to use two functions of pandas libraries. First is info. When we are going to use data.info, it will return all the information about the data, that if there is any null value or what is the data type of the you can say column, right? So we are having three columns. First is our name, then is years of experience, then we have salary, right? So after that, we are going to use the describe function of pandas. Describe function is the function which gives you all the statistical information about your data. We can get mean, max, percentiles, and the different statistical approaches of the dataset. So the next step is to import the matplotlib.pyplot as PLT. Fine. Then we are going to use PLT, which is the function of the Matplotlib library. This is the data visualization library and is very important. Then it is plt.scatter. Then we are going to give our dataset data, and in the square brackets we are going to give the fields, like I am giving years of experience and then again salary. I want these two columns to be plotted in the graph. So it's time to import our linear regression model. So we are going to use scikit-learn library from this. So the code is from sklearn.linear_model import linear regression. Remember, letters L and R must be capital in this, otherwise it will give you an error. So in the next part, we need to classify our x and y variables, right? So next variable, we are going to use years of experience, that is independent variable. So the code will be x is equal to data, square brackets, in which we are going to place our years of experience. Then we are using values dot reshape parentheses -1 and 1. Remember that values and reshape are the functions of the numpy library. Just like this, we are going to classify our y variable, which is the dependent variable, right? Because it is dependent on the years of experience. The more the years of experience, the more the salary will be. So the code is data square brackets. Again, we are placing salary here. Then we are going to close the square brackets, dot values, dot reshape, again parenthesis, -1 and 1. So you need to remember that values and reshape are the functions of the NumPy library. So now we are going to import train test split. It is a machine learning technique that separates a dataset into a training set and a testing set. This technique is used to evaluate the performance of a model. So the code is from scikit-learn dot model underscore selection import train underscore test underscore split. So in this part, we are going to give the ratio of the training and testing data set. So we will write x underscore train, comma x underscore test, comma y underscore train, comma y underscore test is equal to, using technique train underscore test underscore split, again parenthesis, in which we will put x variable, independent variable, and y variable, which is dependent variable, comma test size. So I think ideally we will take 0.2, in which means that 80% for the training dataset and 20% for the testing dataset. So now it's time to make the model. So we will take the variable known as model, in which we will put the linear regression, which we have imported from scikit-learn library. After then, we are using the model to fit on our training set. That is, we will write model.fit parenthesis xtrain and ytrain, and then we will print ytest. Okay, so we have our model, linear regression model, ready with us. So now we can predict the values based on the x-test. So we will take a variable known as ypred or yprediction, and we will use model dot predict. Predict is the function, and we will put x test in the parentheses, which means that model is going to predict the y predictions on the basis of x test. After then, we will print y prediction. Okay, so yes, it got printed. Now okay, so to visualize our result very easily, we are going to make a dataset using pandas library. So we are taking variable name data2, and we are using pandas library here, pd.dataframe. Please keep in mind that d and f must be capital. Then we are going to take the column name as actual, and we are putting ytest actual result in this using flatten function of the going to use the y predictions which we have output, and again using the flatten function. Then we are going to print this dataset. Okay, so yes, we got our dataset now. Okay, so now we are going to plot the xtrain and ytrain points. So using the Matplotlib library, we are going to write the code plt.scatter parenthesis xtrain and ytrain, which will plot our points. So our next task is to plot, or you can say to visualize the dataset 2 which we have made using the actual values and the predicted values. So we are going to write the code data2 dot plot. Plot is a function of the Matplotlib library, parenthesis kind. We need bar chart, so you can write bar, and that's it. Let's run it. Okay, so now it's time to make the linear graph. of this dataset. So we are going to use Matplotlib library for this. So write the code plt.plot parenthesis xprint comma model dot predict xprint, then close the parenthesis comma color. I am writing red, you can write any of your choice. After then close the parenthesis. And in the next line we need to add the title of the graph. It's totally option and up to you whether you want to write it or not. Okay, so we got a perfect graph. When you're working with machine learning, you need to know that you need to check the accuracy of your model. So we will be checking the accuracy of our model using the scikit-learn library. So from scikit-learn.metric import R2 score, we are going to check our model from scikit-learn with the help of R2 score. After then we are using R2 score technique and we are giving our Y test and Y predictions. And wow, we got a 96% accuracy in the model. It's great. Actually, the prediction of the model, or you can say accuracy of the model, must be above 80, and we are having a great numbers of accuracy. So yes, good job. So thank you for watching this video, and you can comment your topics or you can comment the dataset with which you want to do the linear regression practical. So we will do it together. Thank you so much.